Hi, you guys. Welcome to math this morning. We are going to be starting geometry this week. We're going to do a little bit of basic geometry. Remember last week I told you that we're going through some of the things that you need to know for the Math 1 core. So we're going to continue with that this week. And we're going to be using Khan Academy for some of the lessons. I am sure that you guys are a little tired of seeing me teach. Okay, so this week we're going to change it up a little bit and we're going to be watching Khan Academy. So please take out a piece of paper, have something to write with, take some notes. When you are done with these lessons, you will have a quiz to take, okay, at the end. So please make sure that you're paying attention and that you are doing your very best to try and understand what's being taught. Put a star by things that are confusing for you, and we can talk about them after the video lessons are over. Please don't have anything else, like any other screens open while you're watching this video. It needs your full attention if you're really going to learn what you're supposed to. So with that said, I'm going to go ahead and start the first lesson for you.
Let's think a little bit about two terms that you will see throughout your geometry and really mathematical career. One is the idea of things being perpendicular, and usually people are talking about perpendicular, actually I'm misspelling it, perpendicular lines, normally perpendicular lines, and the idea of parallel lines, parallel lines. So perpendicular lines are two lines that intersect at a right angle. So what am I talking about? So let's say that this is one line right over here, and that this is another line right over here. We would say these two lines are perpendicular if they intersect at a right angle. So they clearly intersect. In order for them to intersect at a right angle, the angle formed between these two lines needs to be 90 degrees. And if any one of these angles is 90 degrees, the rest of them are going to be 90 degrees. So if this is 90 degrees, then these are perpendicular lines. And if that's 90 degrees, then that's going to be 90 degrees, that's going to be 90 degrees, and that's going to be 90 degrees. So if any of them are 90 degrees, the rest of them are 90 degrees, and we have perpendicular lines. If you have two lines that on a two-dimensional surface like your paper or like the screen never intersect, they stay the same distance apart, then we are talking about parallel lines. So this line right over here and this line right over here, the way I've drawn them, are parallel lines. They aren't intersecting. They're both kind of going in the same direction, but they're kind of shifted versions of each other. They will never intersect with each other. So these two are parallel. If we have two lines that, let's say they intersect, but they don't intersect at a right angle, so let's say we have that line and we have this line right over here, and they're clearly not intersecting at a right angle, then we call these neither perpendicular nor parallel lines. These lines just intersect.
Okay, so from that video, you learned that two lines that are parallel are never going to intersect, and two lines that are perpendicular intersect to form right angles. So that's the important thing to learn from that lesson. Now we're going to continue with the next lesson.
All sets of parallel and perpendicular lines in the image below. So let's start with the parallel lines, and just as a reminder, two lines are parallel if they're in the same plane, and all of these lines are clearly in the same plane. They're in the plane of the screen you're viewing right now, but there are two lines that are in the same plane that never intersect. And one way to verify, because you can sometimes, it looks like two lines won't intersect, but you can't just always assume based on how it looks. You really have to have some information given in the diagram or the problem that tells you that they are definitely parallel, that they're definitely never going to intersect. And one of those pieces of information which they give right over here is that they show that line ST and line UV, they both intersect line CD at the exact same angle, at this angle right here. In particular, it's at a right angle. And if you have two lines that intersect a third line at the same angle, so these are actually called corresponding angles, and they're the same. If you have two of these corresponding angles the same, then these two lines are parallel. So line ST is parallel to line UV, and we can write it like this. Line ST, we put the arrows on each end of that top bar to say that this is a line, not just a line segment. Line ST is parallel to line UV. And I think that's the only set of parallel lines in this diagram. Yep. Now let's think about perpendicular lines. Perpendicular lines are lines that intersect lines that intersect at a 90-degree angle. So for example, line ST is perpendicular to line CD. So line ST is perpendicular to line CD. And we know that they intersect at a right angle or a 90-degree angle because they gave us this little box here, which literally means that the measure of this angle is 90 degrees. By the exact same argument, line UV is perpendicular to CD. So UV, let me make sure I specify these as lines. Line UV is perpendicular to CD. So I did UV, ST, they're perpendicular to CD. And then after that, the only other information where they definitely tell us that two lines are intersecting at right angles are line AB and WX. So AB is definitely perpendicular to WX, line WX. And I think we are done. And one thing to think about, AB and CD, those are definitely not, well, they don't even intersect in this diagram, so you can't make any comment about perpendicular, but they're definitely not parallel. You can even imagine that it looks like they're about to intersect, and they give us no information that they intersect the same lines at the same angle. So if somehow they told us that this is a right angle, even though it doesn't look anything like a right angle, then we would have to suspend our judgment based on how it actually looks and say, well, I guess maybe those things are perpendicular. And then actually, or maybe these two things are parallel, but they didn't tell us that, and that would actually be bizarre because it looks so not parallel. And actually, then this would end up being parallel to other things as well if that was done. And it's a good thing that wasn't, because it would look very strange. But based on the information they gave us, these are the parallel and the perpendicular lines. Let's say we have two lines over here. Let's call this line right over here line AB. So A and B both sit on this line. And let's say we have this other line over here, and we'll call this line CD. So it goes through point C, and it goes through point D, and it just keeps on going forever. And let's say that these lines both sit on the same plane, and in this case the plane is our screen, or this little piece of paper that we're looking at right over here, and they never intersect. They never intersect. So they're on the same plane, but they never intersect each other. They never intersect. If those two things are true, then, and they're not the same line, they never intersect, and they can be on the same plane, then we say that these lines are parallel. We say that they are parallel. They're moving in the same general direction. In fact, the exact same general direction. If we were looking at it from an algebraic point of view, we would say that they have the same slope, but they have different y-intercepts. They involve different points. If we drew our coordinate axis here, they would intersect that at a different point, but they would have the same exact slope. And what I want to do is think about how angles relate to parallel lines. So right over here, we have these two parallel lines. We can say that AB, line AB, is parallel to line CD, Sometimes you'll see it specified on geometric drawings like this. They'll put a little arrow here to show that these two lines are parallel. And if you've already used the single arrow, they might put a double arrow to show that this line is parallel to that line right over there. Now, with that out of the way, what I want to do is draw a line that intersects both of these parallel lines. So here's a line that intersects both of them. Let me draw a little bit neater than that. So let me draw that line right over there. And I'll just call that line, well, actually I'll do some points over here. Well, I'll just call that line L. And this line that intersects both of these parallel lines, we call that a transversal. This is a transversal line. It is transversing both of these parallel lines. This is a transversal. And what I want to think about is the angles that are formed and how they relate to each other, the angles that are formed at the intersection between this transversal line and the two parallel lines. So we could first of all start off with this angle right over here, that angle right over there, and we could call that angle, well, if we made some labels here, that would be D, this point, and then something else, but I'll just call it this angle right over here. We know that that's going to be equal to its vertical angles. So this angle is vertical with that one, so it's going to be equal to that angle right over there. We also know that this angle right over here is going to be equal to the angle that its vertical angle, or the angle that is opposite the intersection. So it's going to be equal to that. And sometimes you'll see it specified like this, where you'll see a double angle mark like that, or sometimes you'll see someone write this to show that these two are equal and these two are equal right over here. Now the other thing we know is we can do the exact same exercise up here, that these two are going to be equal to each other and these two are going to be equal to each other. They're all vertical angles. What's interesting here is thinking about the relationship between this angle right over here, the relationship between that angle right over there, and this angle right up over here. And if you just look at it, it is actually obvious what that relationship is, that they are going to be the same exact angle. That if you put a protractor here and measured it, you would get the exact same measure up here. And if I drew parallel lines, maybe I'll draw it straight left and right, and it might be a little bit more obvious. That if I draw it, so if I assume that these two lines are parallel, and I have a transversal here, what I'm saying is that this angle is going to be the exact same measure as that angle there. And to visualize that, just imagine tilting this line, and as you take different, so it looks like it's the case over there. If you take the line like this and you look at it over here, it's clear that this is equal to this, and there's actually no proof for this. This is one of those things that are that a mathematician would say is intuitively obvious, that if you look at it as you tilt this line, you would say that that these angles are the same. Or think about putting a protractor here to actually measure these angles. If you put a protractor here, you would have one side of the angle at the 0 degree and the other side would specify that point. And if you put the protractor over here, the exact same thing would happen. One side would be on this parallel line and the other side would point at the exact same point. So given that, we know that not only is this side equivalent to this side, it is also equivalent to this side over here. And that tells us that that's also equivalent to that side over there. So all of these things in green are equivalent, and by the same exact argument, this side right over here this angle is going to have the same measure as this angle, and that's going to be the same as this angle because they are opposite. Now, or they're vertical angles. Now, the important thing to realize is just what we've deduced here. The vertical angles are equal, and the corresponding angles at the same points of intersection are also equal. And so that's a new word that I'm introducing right over here. This angle and this angle are corresponding. They represent kind of the top right corner in this example of where we intersected. Here they represent the top or the top right corner of the intersection. This would be the top left corner, top left corner. They're always going to be equal, corresponding angles. And once again, it comes really just, I guess for lack of a better word, it is a bit obvious. Now, on top of that, there are other words that people will see. We've essentially just proven that not only is this angle equivalent to this angle, but it's also equivalent to this angle right over here. And these two angles, maybe if I call this, let me label them so that we can make some headway here. So I'm going to use lowercase letters for the angles themselves. So let's call this lowercase a, lowercase b, lowercase c. So lowercase c for the angle, lowercase d, and then let me call this e, f, g, h. So we know from vertical angles that b is equal to c, but we also know that b is equal to f because they are corresponding angles. It's equal to f, and that f is equal to g. So vertical angles are equivalent, corresponding angles are equivalent, and so we also know obviously that b is equal to g. And so we say that alternate interior angles are equivalent. So you see that they're kind of on the interior of the intersection. They're between the two lines, but they're on all opposite sides of the transversal. Now you don't have to know that fancy word, alternate interior angles. You really just have to deduce this, what we just saw over here. Know that vertical angles are going to be equal and corresponding angles are going to be equal. And you see it with the other ones too. We know that a is going to be equal to d, which is going to be equal to h, which is going to be equal which is going to be equal to E. Let's say I have an angle ABC, and it looks something like this. So its vertex is going to be at B. The vertex is at B. Maybe A sits right over here, and C sits right over there. And then also let's say that we have another angle called DAB. Actually let me call it DBA. DBA. I want to have the vertex once again at B. So let's say it looks like this. So this right over here is our point D. That is our point D. And let's say that we know that the measure of angle DBA, let's say that we know that that is equal to 40 degrees. So this angle right over here, its measure is equal to 40 degrees. And let's say that we know that the measure of angle ABC is equal to 50 degrees. Is equal to 50 degrees. So there's a bunch of interesting things happening here. The first interesting thing that you might realize is that both of these angles share a side. If you view these as rays, they could be lines, line segments, or rays, but if you view them as rays, they both share this ray BA. And when you have two angles like this that share the same side, these are called adjacent angles, because the word adjacent literally means next to, adjacent. These are adjacent, they are adjacent angles. Now there's something else that you might notice that's interesting here. We know that the measure of angle DBA is 40 degrees and the measure of angle ABC is 50 degrees, and you might be able to guess what the measure of angle DBC is. Measure of angle DBC. If we drew a protractor over here, I'm not going to draw it, it'll make my drawing all messy, but maybe I'll draw it really fast. So if you had a protractor right over here, clearly this is opening up to 50 degrees, and this is going another 40 degrees. So if you wanted to say what the measure of angle DBC is, it would essentially be the sum of 40 degrees and 50 degrees. And let me delete all of this stuff right here to keep things clean. So the measure of angle DBC would be equal to 90 degrees, and we already know that 90 degrees is a special angle. This is a right angle. This is a right angle. There's also a word for two angles whose sum add up to 90 degrees, and that is complementary. So we can also say that angles DBA and angles ABC are complementary. And that is because their measures add up to 90 degrees. So the measure of angle DBA plus the measure of angle ABC is equal to 90 degrees. They form a right angle when you add them up. And this is another point of terminology that kind of related to right angles. When you have a right angle, when a right angle is formed, the two rays that form the right angle, or the two lines that form that right angle, or the two line segments that form that right angle are called perpendicular. So because we know that measure of angle DBC is 90 degrees, or that angle DBC is a right angle, this tells us, so this tells us that DB, if I called them, maybe I could say the line segment DB is perpendicular to line segment BC. Or we could even say, ray BD is, instead of using the word perpendicular, there's sometimes this symbol right here, which really just shows two perpendicular lines. BD is perpendicular to BC. So all of these are true statements here, and these come out of the fact that the angle formed between DB and BC, that is a 90-degree angle. Now, we have other words when our two angles add up to other things. So let's say, for example, I have one angle over here. Let's say I have one angle over here that is, let's just call this angle, so let me put some letters here so we can specify it. So let's say this is X, Y, and Z, and let's say that the measure of angle XYZ is equal to 60 degrees. And let's say that you have another angle that looks like this. you have another angle that looks like this, and I'll call this, let's say maybe MNO. And let's say that the measure of angle MNO is 120 degrees. So if you were to add the two measures of these, so let me write this down. The measure of angle MNO plus the measure of angle XYZ is equal to, this is going to be equal to 120 degrees plus 60 degrees, which is equal to 180 degrees. So if you add these two things up, you essentially are able to go all halfway around the circle, or you could go, throughout the entire half circle or semicircle for a protractor. And when you have two angles that add up to 180 degrees, we call them supplementary. I know it's a little hard to remember sometimes. 90 degrees is complementary. They're just complementing each other. And then if you add up to 180 degrees, you have supplementary. Angles. Supplementary angles. And if you have two supplementary angles that are adjacent, so that they share a common side, so let me draw that over here. So let's say you have one angle that looks like this, and that you have another angle. So let me put some letters here again, and I'll start reusing letters. So let's say that this is A, B, C, and you have another angle that looks like this. No, I already used C. That looks like this. Notice, and let's say once again, let's say that this is 50 degrees, and let's say that this right over here is 130 degrees. Clearly angle DBA plus angle ABC, if you add them together, you get 130 degrees plus 50 degrees, which is 180 degrees. So they are supplementary. So let me write that down. Angle DBA, and angle ABC are supplementary. They add up to 180 degrees. But they are also adjacent angles. They are also adjacent. And because they're supplementary and they're adjacent, if you look at the broader angle, the angle used from the sides that they don't have in common, if you look at angle DBC, this is going to be essentially a straight line, which we can call a straight angle. So I introduced you to a bunch of words here, and now I think we have all of the tools we need to start doing some interesting proofs. And just to review here, we talked about adjacent angles, or I guess any angles that add up to 90 degrees are considered to be complementary. This is adding up to 90 degrees. If they happen to be adjacent, then the two outside sides will form a right angle. When you have a right angle, the two sides of a right angle are considered to be perpendicular. And then if you have two angles that add up to 180 degrees, they're considered supplementary. And then if they happen to be adjacent, they will form a straight angle. Or another way, if you said, if you have a straight angle and you have one of the angles, the other angle is going to be supplementary to it. They're going to add up to 180 degrees. So I'll leave you there.
Hey, you guys, way to hang in there. You just have a couple more minutes left for this lesson, and then I'm going to tell you what your assignment is. So 2 more minutes.
Say that we have two parallel lines. So that's one line right over there. And then this is the other line that is parallel to the first one. I'll draw it as parallel as I can. So these two lines are parallel. So this is the symbol right over here to show that these two lines are parallel. And then let me draw a transversal here. So let me draw a transversal. This is also a line. Now let's say that we know that this angle right over here is 110 degrees. What other angles can we figure out here? Well, the first thing that we might realize is that, look, corresponding angles are equivalent. This angle, the angle between this parallel line and the transversal, is going to be the same as the angle between this parallel line and the transversal. So this right over here is also going to be 110 degrees. Now we also know that vertical angles are equivalent. So if this is 110 degrees, then this angle right over here on the opposite side of the intersection is also going to be 110 degrees. And we could use that same logic right over here to say that if this is 110 degrees, then this is also 110 degrees. We could have also said that, look, this angle right over here corresponds to this angle right over here, so that they also will have to be the same. Now, what about these other angles? So this angle right over here, its outside ray, I guess you could say, forms a line with this angle right over here. This pink angle is supplementary to this 110-degree angle. So this pink angle plus the 110 is going to be equal to 180, or we know that this pink angle is going to be 70 degrees. And then we know that it's a vertical angle with this angle right over here, so this is also 70 degrees. This angle that's kind of right in below this parallel line with the transversal, the bottom left, I guess you could say, corresponds to this bottom left angle right over here. So this is also 70 degrees. And we could have also figured that out by saying, hey, this angle is supplementary to this angle right over here. And then we could use multiple arguments, the vertical angle argument, the supplementary argument, two ways, or the corresponding angle argument to say that, hey, this must be 70 degrees as well.
Hi, you guys. So you are done with the video lessons for today, and now you have your assignment. Today's assignment is a little bit different than assignments we've had in this class before. Today, you are going to have an assignment where you don't do any math problems. All you are going to do is define the following words, okay? So I want you to take out a piece of paper, and I want you to tell me what it means to be parallel lines, what it means to be perpendicular lines. Please explain what a transversal is. If you want to draw a picture for any of these, you can do that, okay? I just need you to explain to me what all of these things mean. Number 4, complementary angles. Number 5, supplementary angles. Number 6, vertical angles. Number 7, corresponding angles. And number 8, straight angle, okay? So like I said, if you want to draw a picture for me and use that to do your explanation, that works great, but this is your only assignment for today, is to tell me what each of these words mean. And I will see you in class on Wednesday for our next lesson. We are going to be continuing with our geometry unit. So have a great day, and if you have any questions at all, know that you can text me or email me. My number is 801-644-9940. Talk to you guys soon.